Today on How It's Made. Wooden bowls. We're dishing out the details. Chainsaws. We'll show you how they make the cut. Stackable potato chips. We go to the factory where the inventory is piling up. And jet compressor blades. An idea that's really taken off. But first, there was a time when bowl making was a cherished trade, passed down through generations of families. But today, with so many inexpensive materials with which to mass-produce tableware, handcrafted wooden bowls have become a speciality item. And this centuries-old traditional craft is almost a lost art. These exquisite bowls are made from a solid piece of hardwood, beech, maple, walnut or cherry. Logs arrive at the mill fresh from the forest, so they're still damp. There's an advantage though, because the moisture lubricates the cutting tools. The first step is to divide it into blocks. The chainsaw operator measures and inspects the log. The length of each block is determined by the diameter and defects such as knots or scarring. He inspects the ends of the block, marking any cracks or other flaws with a red crayon. The ripsaw operator uses different size bowl patterns to determine the best way to cut the block. The goal is to get the most and biggest bowl size pieces possible without using the defective areas. Each piece is called a bowl blank. This block is large enough to yield 3 blanks. Each one is wide enough to produce a 43 centimeter bowl and a series of progressively smaller bowls that nest inside it. They mount the blank on a specially designed woodworking lathe. From this point on, everything depends on the skilled hands of the lathe operator. As the block spins, he carves out the bowls using a series of specialized knives. First, he uses this curved knife to shear off the outer portion. It takes great expertise to know exactly how to angle the tool and when to pull it out to release the wood shavings and prevent a jam. After 2 or 3 minutes, what they call the exterior bark shell has been removed. The bare wood that's left will be the outside of the largest bowl. With a finer blade, he now sculpts the wood to just the right thickness and smooths the surface. Now he switches to a smaller curved knife and cuts into the wood. This both forms the inside of the largest bowl and the outside of the next smaller one. He repeats the smoothing and cutting process with progressively smaller knives, making bowl after bowl at a rate of about 1 a minute. This one bowl blank produces 4 nested bowls, the smallest measuring 23 centimeters in diameter. The bowls are steamed for 4 hours to draw out the sap and penetrate the pores of the wood, hydrating each bowl, preventing cracks and splits while air drying. Once a bowl is dry, about a month later, workers even out the top rim on a sanding table. Then using a belt sander, they smooth the outside and inside surfaces. The bowl now goes upside down through a specialized knife that shaves off part of the bottom. This gives the bowl a flat base on which to sit and a place to inscribe the company name. Businesses can order custom-made bowls featuring their company logo. Artists burn the design onto the wood or paint it on. or do a combination of both. The bowls now go for a bath in a non-toxic mineral oil. This nourishes the wood, preventing dryness and cracks. Oiling also brings out the natural beauty of the wood grain. And because every raw log is unique, each dish will really bowl you over. It's loud, it's powerful, and it rules the forest. The chainsaw has revolutionized the logging industry by replacing mortal muscle with mechanical torque. It's made the work a whole lot easier, so it continues to be a rip-roaring success. The chainsaw can set up any tree for a big fall, and then chop it up. These machines start with the plastic housing. 3 aluminium inserts will be molded into it to provide solid anchors to attach other parts. A robot picks up the inserts one at a time and delivers them to an injection molding machine. The robot strategically places the inserts in a mold at the front of the machine. The machine then injects molten plastic into the mold to make the chainsaw's engine cover. During the molding, the metal inserts become integrated into the housing. It takes just seconds to transform these plastic pellets into a chainsaw engine cover. The robot carries each engine cover to automated cutters that remove any unwanted plastic. The scrap drops into a bin below. A robot then places each engine cover in a special fixture to cool for about 10 minutes. Then it moves the part to the next station. There's one more piece of plastic housing, the fuel tank. This sonic welder melts and fuses it to the engine cover using high-frequency vibration. Now they move to the engine and install a spring system for the starter cord. They slide the 2-stroke engine into the plastic casing and insert a spark plug. They lubricate the crankshaft, then install an automatic oiling system for the saw chain. The carburetor is attached, and then the starter system with the pull cord handle. The air filter is fitted into its slot. Then stud bolts for the chain bar are dipped in adhesive and screwed into the inserts molded into the plastic housing. They attach the rear handle and a trigger with a safety release. Then they screw the front handle into place. A filter is attached to the oil line that lubricates the bar and chain. It will strain out any impurities. Now they install bearings and the clutch system on the crankshaft. The clutch is the link between the engine and the chain. When it's engaged, the chain moves around the cutting bar. The engine is ready for a test run at a typical speed of 8,000 RPM. They adjust the carburetor so that it mixes the right amount of fuel and air, and check the exhaust to make sure it doesn't exceed pollution laws. They attach the trademark sticker and other operational information. Then they attach a brake system. Finally, they pack the metal bar and chain blade in a protective sleeve. Once the operator installs the chain blade, he has a power tool with teeth for any job. That's one clever fella. Coming up on how it's made. Special crisps that you can stack neatly. And clever bits of kit to keep you in the air. See you after the break. Each stackable crisp is made exactly the same, unlike others that come in irregular shapes and sizes. This uniform concave shape allows the crisps to tightly interlock, so you can fit a lot of them in a tubular container. It's a snack that's made to stack. Whether you call them chips or crisps, this is a case of production going down the tubes. To make these tubes, big rolls of plain brown paper and foil-backed paper unwind. The foil will help keep the crisps fresh. The streams of paper travel across rollers that coat them with glue. The paper layers twist around a mandrel that's turned by a belt. The belt also presses the glued layers together. Next, the label paper gets a coat of glue. This helps it stick to the paper on the mandrel. A camera photographs the white edging on the label paper, then relays its location to a set of circular knives. They make a precise cut below the white edging. After each cut, the carriage moves the knives into position for the next one, cued by the camera. These paper and foil tubes head into a turning station. It's a box with a pathway inside that turns the tubes right side up. Hot metal heads curl the tops to allow lids to fit on. A roller pulls foil-backed paper into a cutter that punches out the lid shapes. Small vacuums take the lids to the tubes and heat seal them on. Plastic lids go over the paper ones. The lidded tubes are now turned upside down. They're ready to be stacked with chips. They use a ratio of 1/3 water to 2/3 potato flakes, with a little cornstarch mixed in. A conveyor delivers the mix to an auger, which dispenses it. Then it falls between the rollers. Using 4 tons of pressure, they roll the mix into one long potato sheet. The potato sheet goes under a rotary cutter that punches out oval shapes. A device pulls away the scrap dough, leaving flat, uncooked crisps. This scrap dough goes back into the operation, while the crisps head into a fryer. As they travel through the fryer, rolling molds make them concave. The concave shape makes the crisps stackable. They spend 11 seconds frying in hot oil. This makes them crispy. They travel under blowers to get rid of excess oil. They then get a coat of seasoning and flip off one conveyor and onto another, falling in neat piles. A worker inspects the rows of crisps. Then it's onto another conveyor that shakes them to loosen the pack. They travel over scales to portion them out for packaging. Automated spoons feed the crisps into the open ends of the tubes. Guides tap the top of the tubes to nudge the crisps into position. Grippers then lower the stacked tubes to a station where spinning heads force metal bottoms onto them. Now they're ready for shipping. It takes about 20 minutes to make a tube of stackable chips, quite a lot longer than it takes me to empty them. Compressor blades are key components in a jet's engine. Thousands of them rotate 400 times per second, whipping air into small hurricanes. They compress the air, making it so hot and dense that it literally explodes when mixed with fuel in the combustion chamber. In a jet engine, large compressor blades made of titanium compress the air entering the front of the turbo chamber. They move the air toward the back of the chamber, where smaller blades made of nickel alloy compress it even more. The air heats up to more than 600 degrees Celsius that combines with jet fuel, creating a powerful mix that produces the thrust. The blades start off as metal pellets called slugs. A ceramic layer prevents their surface from oxidizing when exposed to intense heat. The slugs are heated for 15 minutes in a 980 degrees Celsius oven. Meanwhile, a robot sprays lubricant on 2 forming dies inside a press. The robot retrieves the slugs and loads them into the first die. The press applies 1,000 metric tons of pressure to preform the metal. The robot then transfers the slugs to the second die, where they take the initial shape of the blade. The blades are then dipped in water to cool. The next robot cleans the metal burrs off the edges. The blade is now an aerofoil. Robots will shape the rounded base of the blade, called the dovetail, later. The aerofoil has gone from this to this. After a new ceramic layer is applied, the blade is once again heated in a convection oven to 980 degrees Celsius. Each heating and cooling cycle tempers the metal, making it more resilient. 1,600 metric tons of pressure gives the aerofoil its final shape. A trimmer shaves off the excess metal. The heat has turned the protective ceramic layer into glass. It'll later be removed. It's taken an hour to shape the blade's aerofoil. The dovetail, the nub on the right, is next. But first, this measuring machine inspects the aerofoil. If any measurement is off by just half the thickness of a human hair, the blade is rejected. The casting machine will encase the aerofoil in a matrix, a coating that protects the aerofoil during work on the dovetail. They mold the matrix from liquid tin and bismuth. It solidifies into a metal cast around the aerofoil. The future dovetail sticks out at the end. They load the cast into what's called a broach machine, with a series of teeth that carve the dovetail to its final shape. Now the cast can come off. A worker loads it onto the removal machine. A hydraulic cylinder hits the cast at its weakest point, breaking it in half. The finished aerofoil emerges unscathed. A dot matrix machine punches identification numbers onto the blade. Next, they submerge the blades in fluid that penetrates any flaws in the metal. This inspection is critical because even the tiniest nick can spell disaster. They examine the blades using ultraviolet light. This blade is perfect, but spots of fluorescence on this one indicate microscopic cracks and weaknesses. The dovetail gets 2 strips of rubber silicone that ensure an airtight seal when the dovetail slides into its slot on the compressor drum. A final check, and the blades are now ready for takeoff. So, whether you're looking for something dishy that'll really bowl you over, or after a slice of cutting-edge technology, or perhaps you just want to stack up on those carbs, now you know how it's made.